Proof by induction that sum of r over r plus 1 factorial equals to n plus 1 factorial minus 1 over n plus 1 factorial, where r start from 1 all the way to n. To start, we do operation 1, base case, to show that the statement is true for n equals 1. To do that, we look at the left-hand side and the right-hand side. This is the left-hand side and that is the right-hand side. And for the left-hand side, where n equals to 1, you start with r equals to 1 and you get to n, which is 1. So this has to be 1. So you would get 1 for that one over 1 plus 1 factorial, and that equals 1 over 1 plus 1, which is 2 factorial. And 2 factorial is 2 times 1, and that equals to 2. So you get 1 over 2. For the right hand side, you basically let n equals to 1, and so that's 1 plus 1 factorial minus 1 over 1 plus 1 factorial, and that equals to, this is 1 plus 1 factorial, that's 2 factorial, factorial minus 1 over 2 factorial, and that equals to 2 minus 1 is 1, 2 factorial is 2 times 1, that's 2. So therefore, we got a half for the right hand side, a half for the left hand side. Therefore, for the base case, we're able to show that the statement is true for n equals to 1. Step 2. Inductive hypothesis. Assume the statement is true for n equals k. Here is the equation again. We need to change n equals k, so we change n to k by transforming the n equals k. So we have n plus 1, replace n with k, so you get k plus 1 factorial minus 1 over k plus 1 factorial. And we're going to use this step 2, the inductive hypothesis, in step 3. Step 3, inductive step. Prove the statement is true for n equals k plus 1. So what we do is bring back the equation, that's the equation, and we're going to replace n with k plus 1. N is now k plus 1, and I'm going to put k plus 1 here, that will be k plus 2. 1 plus 1 is 2. Factorial minus 1 over k plus 2, because there's a k plus 1 plus 1. That's k plus 2 factorial. Now, this is what we're going. This is the solution we want to derive using step 2, the inductive hypothesis. So we're going to use step 2 to derive this. So let's go for that. Here's the equation again. Now I'm writing the step 2. So this is k plus 1 term. This is k, r equals 1 to k plus the k plus 1 term. So I'll replace that with k plus 1 and that with k plus 1. K plus 1 will make it k plus 2 factorial. So this is the last term. This is the term from 1 to k. So that will be equal to, this is step 2, the inductive hypothesis. That's what we got when we replace that with k. And now we're going to add the last term. This is the last term. So when we simplify this, we should get that. So what we now need to do is, this is k plus 2 factorial. This is k plus 1 factorial. I want to make them the same denominator. So the best is to multiply that, k plus 2. For example, k plus 2 factorial will be equal to k plus 2 times k plus 1, because it will be decreasing by 1, and you multiply it, times k minus 1 times k minus 2 all the way to 1. The k plus 1 times k all the way to 1 is what we called, this one is k plus 1 factorial. So that will be equal to k plus 2 times k plus 1 factorial. I've already got k plus 1 factorial here. If I times it by k plus 2, I will get k plus 2 factorial. And this is k plus 2 factorial. So I need to times the top and bottom by k plus 2. K plus 2 times k plus 1 factorial times minus k plus 2. This will be 1 times k plus 2 over k plus 2 times k plus 1 factorial. So I'm just multiplying top and bottom by k plus 2 plus the last term. Plus that is I'm changing this top here. I'm multiplying the top and bottom by k plus 2 and k plus 2, because now they have common denominator now. So that would be that. So this is k plus 2 factorial minus k plus 2 over k plus 2 factorial plus k plus 1 over k plus 2 factorial. Remember, this is what we need to show. We need to derive this. This is the equation that we have. This is the equation we've arrived at. Now we need to simplify this. We're trying to get to here. So the next thing we need to do is to keep them in common denominator. So that minus k plus 2 plus k plus 1 over k plus 2 factorial, because they have this common denominator. So we just add the numerators. And now we need to open the bracket here and simplify the top. So we get k plus 2 factorial minus k minus 2, because minus times k is minus k, minus times plus 2 is minus 2, plus k plus 1 over k plus 2 factorial. Minus k cancels plus k, minus 2 plus 1 is minus 1. So that's the minus 1 there. So we get k plus 2 factorial, that one, minus 1 over k plus 2 factorial. And that's the solution we're looking for. Step 4. We need to write the inductive statement. And the statement to get a full mark. There are 4-point statements. The first one is, since this statement is true for n equals 1, and if this statement is true for n equals k, we have to write this down, write that down. Then it is true for n equals k plus 1. We need to write it down. Finally, the statement must be true for all n greater than 1 or equal to 1. All 4 statements must be written to get the full mark.